Our next section is about the squeeze theorem. By the way, you might also hear this called the sandwich theorem. Squeeze theorem I think is more common though, but both names are used for it. So here's the squeeze theorem. I'll go over what it means in just a second. You might be looking at this and be like, that doesn't even look like English. That's fine. I'll draw you a picture and then we'll do an example. So this is saying if f of x is between h and g for all x in an interval containing c, and if the limits of h and g as x approaches c are both equal to the same thing, then the limit of f is also that same thing. So let's do, first of all, before we do an example, I'm going to draw you a picture so you can see what's going on. So in this picture, you'll notice so far I have two functions. I have my g of x and I have my h of x. You'll notice also that those functions at c have the same limit, which I called L. So basically what this theorem is saying is that if you have two functions that have the same limit at a certain point, by the way, you'll notice like it doesn't have to necessarily be continuous. My h, I have an open circle, but the limit still is at L. So if you have two functions that have the same limit, then a function that is completely in between them, which I called f, is also going to have that limit. So that's what's happening here. By the way, I want you to keep in mind, you can even write this down if you want, that whenever you have a theorem, the first thing that you need to do with a theorem is you have to verify that the if statements are true. That after you do that, then you can make the conclusion with the then. So you have to verify that the if statements are true, then you make that conclusion. So I'll explain what I mean in just a second. So let's go ahead and do this example. So they tell us that f of x is between 3x and x cubed plus 2 for all values of x between 0 and 2. They want us to evaluate the limit as x approaches 1 of f of x. First thing I'm going to do is draw a picture of those two functions. So this is what these two functions look like. Graphs aren't perfect because I'm drawing on my iPad, but if you want to graph them on a calculator, if you want to use Desmos, you can do that. You might notice that at x equals 1, both of these functions actually are equal to 3. That's a good thing. That's what we want. So we don't actually know what f of x is. All we know is that f of x is between these two functions. So it could be like all sorts of crazy stuff, but it is always between those, between 0 and 2. It's not necessarily between them before that, even though I drew that, but between 0 and 2, it's right between the green and the blue functions. So that red one is my f of x. So now let's go ahead and let's do this problem. You might be able to actually do it just by looking at it, but if you just put an answer for this, that's not going to cut it for, if you were doing that on the AP test, you might get like 1 point out of 3 or 4. So you need to do a little bit more than that. So I'll show you what you need to do. So the first thing you need to do is, you'll notice I put the squeeze theorem right here. We need to verify the if statements. And the first one they actually give to us. If something is listed in the problem, you don't necessarily need to verify it again. You can rewrite this whole thing. That is the first part of the if statement for all x in the interval containing c. In this case, by the way, c equals 1. So first part of the statement is fine. The second part of the statement, they say if these two limits are equal. So our c in this case is 1. We need to find two things. We need to find the limit as x approaches 1 of 3x, and we need to find the limit as x approaches 1 of x cubed plus 2. Hopefully these are equal, otherwise we can't use the squeeze theorem. So these ones are really nice because you just need to plug in the value. And when you do that, you plug in 1 for x for both of them, and you do get 3. So I'm going to actually write a nice little answer. You don't need to write as much stuff as I do. You can probably guess, by the way, the answer is 3. But I'll show you what you would want to write to get full credit on this type of problem. So this right here, everything I wrote in blue, would be a very strong response on the AP test. Even better to say by the squeeze theorem, because when you actually get a test, same thing in college also, when you actually get a test with this type of thing on it, they're not going to say use the squeeze theorem. Usually they won't. Occasionally they will, but usually not. So I said since f of x is between 3x and x cubed plus 3 for x is between 0 and 2, and the limit as x approaches 1 of 3x and limit as x approaches 1 of x cubed plus 2, then the limit of f of x as x approaches 1 equals 3 by the squeeze theorem. So something like that, perfect way to write it. If you're even more articulate than I am, then you might even write something better. But it's good to include, make sure that you verified that the if statements are true, and then you can come to your conclusion and get your answer. And that's going to be the way it will be in this class with all theorems, and the way that you should do it both in college and on the AP test. Most theorems will have an if-then statement, so make sure that you verify the if, and then you can come to the then conclusion.